volume is equal to 4 by 3 pi r cube. Z is equal to x plus 5. So derive with respect to time. dz by dt is equal to dx by dt plus dy by dt. If you want to show the given function is minimum, we have to show that the second order derivative is positive. Area is equal to 4 pi r square. Have a function in the exponential form, you have to apply log on both sides. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. We are at the revision chapter wise question and answer, and in this session I'll be taking the revision on the chapter application of derivatives. In our previous session of this chapter, we have looked upon the questions for 2 marks as well as 3 mark question. In this session, I'll be continuing few more problems on 3 mark question. So before starting, let us see how the distribution of marks will be there from this chapter. So in this chapter, you will be having 1 2 mark question, 2 3 marks question. So total 8 marks. Let's start solving the questions in today's session. Our first question is, the volume of a spherical ball is increasing at the rate 4 pi cc per second, that is cubic centimeter per second. Find the rate of increase of the radius of the ball when the volume is 288 pi cubic centimeter. We know that the volume of a sphere is 4 by 3 pi r cube. They have given the rate of change of volume, that is they have given dV by dt. So how much they have given? It is 4 pi cc per second. Now we need to calculate the change in radius, that is dr by dt whenever volume is 288. So here volume is given 288 is equal to 4 by 3 pi r cube. 288 pi, so pi get cancels, so 288 into 3 divided by 4, so that is equal to r cube. So we get as 216. So if r cube is 216, 216 is 6 cube. So therefore we will get r is equal to 6 centimeter. Now let us derive this formula with respect to t now. So we get dv by dt is equal to 4 by 3 pi is a constant. So let's write as it is 4 by 3 pi r square into dr by dt. So we can cancel 3. Here we have 4 pi is equal to 4 pi r square is 6 square dr by dt. We can cancel 4 pi, 6 square is nothing but, so we get 1 by 36, which is dr by dt. So centimeter per second. So this is the change in radius with respect to time. Next question. A ladder of 15 feet long leans against a smooth vertical wall. If the top slides downwards at the rate of 2 feet per second, find how fast the lower end is moving when the lower end is 12 feet from the wall. So here is a wall and here is a ladder leaning against a wall. So this is the bottom. So the ladder is 15 feet long, and as the base of the ladder move, so here the ladder comes downwards or slide downwards from the wall. So it comes downwards. So let me take this distance, total distance as y, and this total distance as x. So clearly we can observe this is in the form of a right angle triangle. Also they have given that if the top of the slide downwards at the rate of 2 feet per second, that dy by dt, since it comes downwards at the rate of 2 feet per second, we need to calculate, however the lower end is moving, we need to calculate dx by dt. So when the lower end is 12 feet from the wall, when x is equal to 12 feet from the wall. So first let us calculate y, x, then we can find out dx by dt. So from the figure, I can write x square plus y square is equal to 15 square. X square is given, it is at 12 feet. So 12 square plus y square is equal to 15 square. Or I can write y square is equal to 225 minus 144, which is equal to 81. So therefore I can take y is equal to 9. Now I got y is equal to 9. Now let us derive this equation. So let me take this as equation 1. Now derive equation 1 with respect to time. So we get 2x into dx by dt plus 2y into dy by dt is equal to 0. Again we have 2 as a common factor. So we can take out 2 or divide 2 throughout. We get x into dx by dt plus y into dy by dt is equal to 0. Given x is equal to 12, dx by dt, y we got it as 9, dy by dt is given as 2 is equal to 0. We get dx by dt is equal to minus 18. 9 2s are 18, we can shift here. 12 we can shift here. So divide by 12. So after dividing it, we will get minus 3 by 2. Since this is the distance moving with respect to time, we can write this as 3 feet per second. The negative shows the direction here. So negative symbolizes the direction of the ladder moving or sliding down from the wall. So therefore, the bottom of the ladder is moving at the rate of 3 by 2 feet per second. Next one, find the maximum and minimum value of the function. So to find the maximum and minimum value of the function, given f of x is equal to 2x cube minus 3x square minus 12x plus 12, find f dash of x. So f dash of x becomes 6x square minus 6x minus 12. Now to find the critical points, put f dash of x is equal to 0. So if you put f dash of x is equal to 0, we get 6x square minus 6x minus 12 is equal to 0. Divide the equation throughout by 6. Since x is a common factor, I will get x square minus x minus 2 is equal to 0. Or I can write this as x square minus 2x plus x minus 2 is equal to 0. X common, x minus 2 plus 1, x minus 2 is equal to 0. I will get x minus 2 into x plus 1 is equal to 0. So therefore, I get x is equal to 2 or x is equal to minus 1. So these are the solutions or the critical points for the given equation. Now let us derive again f dash of x. Find the second derivative, that is f double dash of x is equal to, so we have here 6x square, so which becomes 12x, minus 6x is 6, minus 12 is 0. Now we have the critical points. Let's see what happens at x is equal to 2. At x is equal to 2, f double dash of x is equal to 12 2s are 24 minus x. So we get it as 18, which is greater than 0. So this implies f of x has minima. So therefore, if f of x has minima, then I can take f of 2. So what is f of 2 here? So find the value, 2 cube, 8, 16 minus, we have 3x square, 2 square is 4, 4 3s are 12. Next we have minus 12x minus 24 and the last term is the constant term, that is plus 12. So solving this, we get x is equal to minus 8. So this is the minimum value. Now let's see, at x is equal to minus 1. What happens? F double dash of x is equal to 12 into minus 1. So we will get minus 12 minus 6, which is equal to minus 18, which is less than 0. If the second order derivative is less than 0, that means f of x has maxima. So if f of x has maxima, so therefore f of minus 1 will be equal to 2x cube, that is minus 2. Next we have 3x square, which becomes minus 3. Next we have 12 into minus 1, so we have plus 12, and the last one we have again plus 12. 24 minus 5 is 19. So this is the maximum value of the given function, and minus 8 is the minimum value of the function. Next one, the side of an equilateral triangle is increasing at the rate of √3 centimeter per second. Find the rate at which its area is increasing when the side is 2 meter. So let me take the side as A. So therefore change in side, I'll take it as dA by dt, √3 centimeter per second, and we have to find the change in area whenever the side is 2 meter. Now before solving the problem, here the change in the side is given by centimeter, whereas side is given as 2 meter. So let us convert it into centimeter. So this can be written as 200 centimeter. Now we know that the area of an equilateral triangle is given by √3 by 4 a square. So derive it with respect to time. We get dA by dt is equal to √3 by 4 2a into dA by dt. Let us substitute the values. We have dA by dt is equal to √3 by 4 into 2 into 200. Next we have into dA by dt is √3. So we can cancel here, 4 ones are 400. So √3 into √3 is 3, 3 into 100 is 300 centimeter square per second. So this is the change in area of an equilateral triangle. Next one, find two positive numbers whose sum is 14 and sum of whose squares is minimum. So given that x plus y is equal to 14 and given the sum of their square, x square plus y square, is minimum, we have to show that. Let me take s is equal to x square plus y square. Now from this I can take y is equal to 14 minus x. So here I will get x is equal to x square plus 14 minus x whole square. So s is equal to x square plus 14 square is 196 plus x square minus 14 2s are 28x. So I can take x is equal to 2x square minus 28x plus 196. Now derive it, ds by dx. So we will get 4x minus 28. So now put x, ds by dx is equal to 0. So therefore ds by dx is equal to 0 implies 4x minus 28 is equal to 0. So therefore I'll get x is equal to 7. Now again derive this equation, that is d square s by dx square. So when you derive it, you will get the value as 4, which is greater than 0. So that means f of x has minimum. F of x has minima. So that means the given function is minimum. So therefore the numbers are 7 and y we have taken as 14 minus x, which is 14 minus 7, that is equal to 7. Hence both the numbers are 7 and 7. Next one, the surface area of a spherical soap bubble increasing at the rate of 0.6 centimeter per second. Find the rate at which its volume is increasing when its radius is 3 centimeter. So they have given the surface area is changing, that is dA by dt is changing, that is 0.6 centimeter square per second. We have to find out the change in volume whenever r is equal to 3 centimeter. Now here we have dA by dt. So dA by dt area is given by 4 pi r square. So dA by dt is nothing but 4 pi into 2r into dr by dt. So this is given 0.6 is equal to 4 pi and 2r is nothing but 6 dr by dt. So here 0.6 can be written as 6 by 10, 4 pi into 6 dr by dt. We can cancel 6 and 6 on both sides. So we will get dr by dt as 1 divided by 40 pi. So since it is given in centimeter, we can write it as centimeter per second. Now we have got the change in radius. Once you got change in radius, you can find the volume. That is, we know that volume is equal to 4 by 3 pi r cube. So therefore, dV by dt can be written as 4 by 3 pi r cube. If you derive, you will get 3r square into dr by dt. So 3 get cancels. We have 4 pi. R square is 6 square. Dr by dt is 1 by 40 pi. So 4 pi, 10s are cancels. We will get 36 divided by 10. So dV by dt. So therefore we get dV by dt, 36 by 10 can be written as 3.6 centimeter cube per second. So this is the rate of change of volume whenever the radius is 3 centimeter. Next one, the volume of a sphere is increasing at the rate of 4 pi cc per second. Find the rate at which area of its surface increases when the radius is 10 centimeter. So the volume is given, that is V is equal to 4 by 3 pi r cube. Change in volume is dV by dt, and 4 by 3 pi r cube is 3r square with respect to change in radius. Now volume is given, that is 4 pi. Here 3 get cancels, 4 pi r square and dr by dt. So the radius is given, that is 10 square. We can cancel 4 pi. We will get 10 square is 100 into dr by dt. So therefore I will get dr by dt is equal to 1 by 100 centimeter per second. Next we need to calculate the surface area, that is area is equal to 4 pi r square. So change in area is dA by dt 4 pi 2r dr by dt. So dA by dt is equal to 4 pi 2 10s are 20, dr by dt is 1 by 100. So here we can cancel 21s are 25s are. So therefore change in area, that is dA by dt can be written as 4 pi by 5 centimeter square per second. So this is the change in area whenever the radius is 10 centimeter. Next one, show that x to the power x is minimum at x is equal to 1 by e. If you want to show the given function is minimum, we have to show that the second order derivative is positive. Let's find out. So let y is equal to x to the power x. So since you have a function in the exponential form, you have to apply log on both sides. So then you will get log y is equal to x log x. So here you have 1 by y, dy by dx, product rule on your right hand side, first function into derivative of second plus second function into derivative of first, and here you have dy by dx is equal to y into x cancel 1 plus log x. Now this is your first order derivative. Now let's find the critical point. So here we need put this as 0. So if this is equal to 0, we get y into 1 plus log x, or I will get 1 plus log x is equal to 0. So I'll get log x is equal to minus 1, or I can take this as x is equal to e to the power minus 1, or I can take x is equal to 1 by e. So this is the solution. Now we got x is equal to 1 by e as the critical point. Now let us derive this equation again. So d square y by dx square. Again apply the product rule because we have two functions, y and 1 plus log x. First function, derivative of second, that is 0 plus 1 by x, plus second function into derivative of first, that is dy by dx. So here we have d square y by dx square is equal to y divided by x plus 1 plus log x. And here again you can substitute dy by dx as y into 1 plus log x. So here we get d square y by dx square is equal to, you can take y as a common factor, you will get 1 by x plus 1 plus log x whole square. Now here substitute x is equal to 1 by e. So at x is equal to 1 by e, so y d square y by dx square. So y is nothing but x to the power x. So therefore I can write 1 by e whole to the power 1 by e. And here 1 over 1 by e plus 1 plus log 1 by e whole to the power square. So this is a square function which is positive plus a positive function plus again a positive function. That means this is greater than 0. Since the second order derivative is greater than 0, what we can conclude? F of x is minimum at x is equal to 1 by e. So to show that the given function is minimum, we have to show that its second order derivative is a positive function. To show that f of x is maximum, the second order derivative function is a negative value. A man 2 meter height walks at a uniform speed of 6 km per hour away from the lamppost of the height 6 meter above the ground. Find the rate at which the length of his shadow is increasing, rate at which the tip of his shadow is moving. So here is a lamppost and here is a man. So the given height of the man is 2 meter and the height of the lamppost is 6 meter above the ground. So this is the ground. So given a man 2 meter height walks at a uniform speed 6 km away from the lamppost. He is moving 6 km away from the lamppost. So after moving away from the lamppost, we have to find out the length of his shadow increasing. Once he moves away from the lamppost, the shadow will increase. Also, we have to find out the tip of the shadow increasing. Now, let me complete this diagram. So, let me take this as A, B, C, D, E. Let me take this distance as x, this distance as y, and the total distance as x. That is the tip of the shadow moving from here to here. Now from diagram, from figure, we can write AB divided by CD is equal to BE divided by DE. So AB is nothing but 6, CD is nothing but 2, BE is nothing but x plus y, and DE is nothing but y. So we can cancel. We get 3y is equal to x plus y, or we get 2y is equal to x. So differentiating this implies 2 into dy by dt is equal to dx by dt. So dx by dt is given. The man is moving 6 km per hour from the lamppost. That is, rate of change of x is given. Hence we can take dx by dt as 6 km per hour. So cancelling 2 1s are 2 3s are, we get dy by dt is equal to 3 km per hour. So that is, y is nothing but the length of his shadow is increasing. Hence the length of the shadow increasing at the rate of 3 km per hour. Next, we need to calculate rate at which the tip of the shadow is moving. The tip of the shadow starts from here to here, that means z. So therefore, we have z is equal to x plus y. So derive with respect to time. dz by dt is equal to dx by dt plus dy by dt. So is equal to 6 plus 3, which is equal to 9 km per hour. Hence the tip of the shadow is moving at the rate of 9 km per hour. Next one, A square plate is expanding uniformly. The side is increasing at the rate of 5 centimeter per second. What is the rate at which the area and its perimeter is increasing when the shadow is 20 centimeter long? So given the rate of change of side with respect to time. So that is 5 centimeter per second. So we need to calculate the rate of change of area as well as the perimeter when the side is 20 centimeter. So we know the area of a square is a square. So therefore change in area dA by dt will be 2a into dA by dt. So that is 2 into 20 into 5. So therefore dA by dt will be equal to 200 centimeter square per second. Next we need to calculate the change in perimeter. So perimeter of a square is nothing but 4a. So therefore dP by dt is nothing but 4 into dA by dt, which is 4 into 5, which is equal to 20 centimeter per second. Hence, the change in area is 200 centimeter square per second. Change in perimeter is 20 centimeter per second. Next one, the edge of a variable cube is increasing at the rate of 6 centimeter per minute. How fast is the volume and its surface area increasing when the edge is 10 centimeter long? So we know that an edge of a variable cube means a cube is a solid where all its edges are equal. Hence, I'll take the edge as A and change in the edge with respect to time is given as 6 centimeter per minute. Now we need to calculate the volume and the surface area increasing, that is change in volume and change in surface area when the edge is 10 centimeter long. So the area of a cube is given by 6a square. Hence dA by dt is nothing but 6 into 2a into dA by dt. So that is equal to 6 into 2 into 10 into 6. The change in area of a cube with respect to time is 720 centimeter square per minute. Next we need to calculate the change in volume. The volume of a cube is given by a cube. So therefore change in volume is dV by dt is equal to 3a square into dA by dt. So therefore dV by dt is equal to here 3 into 10 into 6. So the volume is 1800 centimeter cube per minute. Hence this is the change in area and this is the change in volume. Next question. Divide the number 40 into two parts such that their product is maximum. So let us take 40 as a sum of two numbers and given that their product is maximum. To show that their product is maximum, we have to show that its second order derivative is a negative. So therefore, here from this I can take y is equal to 40 minus x. So here I can take x into 40 minus x. So the product becomes 40x minus x square. Now let us derive this with respect to x. dP by dx is equal to 40 minus 2x. So to find the critical point, put this value is equal to 0. Then we get 40 minus 2x is equal to 0. Therefore, 2x is equal to 40 implies x is equal to 20. Once you got the critical point, find the second order derivative, that is d square p by dx square. So what is d square p by dx square? It is minus 2. So minus 2 means it is less than 0. So that means it has maxima. Hence we have concluded that their product is maximum. So therefore x is equal to 20 and y is equal to 40 minus x, that is 40 minus 20 is equal to 20. So therefore the numbers are 20 and 20. So hence we have divided the number 40 into two parts as 20 and 20. So all these type of questions carries 3 marks, and you can expect these type of questions from this chapter. We'll meet you in the next session with the new chapter. Until then, keep watching, keep learning, keep exploring. Thank you.